Problem 5. Using a reciprocal function. Clubs. The rowing club is renting a 57-passenger bus for a day trip. The cost of the bus is $750. 5 passengers will be chaperones. If the students who attend share the bus cost equally, what function models the cost per student C with respect to the number of students N who attend? What is the domain of the function? How many students must ride the bus to make the cost per student no more than $20? First, consider what you know. You know the bus holds 57 passengers. You also know the bus costs $750. And you know 5 riders are chaperones who pay nothing for the bus. Next, consider what you need. You need a function for the cost per student. You also need the number of students needed so that the cost does not exceed $20 per student. So your plan. Write the reciprocal function for the situation. Graph the function and solve an inequality using the $20 limit. To share the cost equally, divide 750 by the number of students N who attend. The function that models the cost per student is C equals 750 divided by N. The bus has a capacity of 57 passengers and there will be 5 chaperones. The maximum number of students is 57 minus 5, the chaperones who will not be paying, and that equals 52. The domain is the integers from 1 to 52. Only those values make sense in this situation. We'll exclude values like 1.5 because 1.5 students riding the bus doesn't make sense. Next, we use a graphing calculator to solve the inequality. 750 divided by n is less than or equal to 20. Recall we want to find how many students it takes to attend to make the cost per student less than or equal to $20. To graph this inequality, we'll let y1 equal 750 divided by x and y2 equal 20, essentially turning this single inequality into a system of equations and finding the intersection and all points where 750 divided by n is less than or equal to 20. We can change the window dimensions to get a closer look at the graph, particularly the point of intersection, and we'll use the intersect feature, or if graphing on Desmos, simply click the point of intersection to reveal its coordinates. We know the number of people riding the bus must be a whole number, so we could either estimate this as 37 or 38 depending on the problem, but since we want the value to be less than or equal to 20, we'll need the next whole number of students greater than 37.5. If we round down to 37, we wouldn't have enough students to make the cost per student under $20. And that's shown here. If x equals 37, the cost will be more than $20. So we can state, for all values greater than or equal to 38, the cost is less than $20. And our final answer, in a complete sentence, is at least 38 students must ride the bus. Your turn. The junior class is renting a laser tag facility with a capacity of 325 people. The cost for the facility is $1,200. The party must have 13 adult chaperones. Part A. If every student who attends shares the facility cost equally, what function models the cost per student C with respect to the number of students N who attend? What is the domain of the function? How many students must attend to make the cost per student no more than $7.50? Part B. The class wants to promote the evening by giving away 30 spots to students in a drawing. How does the model change? Now, how many paying students must attend so the cost for each is no more than $7.50?